Hello everyone, this is the model answer for the Radiation Foundation exam questions. Alpha, beta and gamma are types of nuclear radiation. Draw one line from each type of radiation to what the radiation consists of. So, alpha particle. If we look through, there's only one of these that an alpha particle can be, and it is 2 protons and 2 neutrons. A beta particle. Now, a beta particle is a high energy electron and get emitted from the nucleus during radioactive decay. And then gamma. Gamma is part of the electromagnetic spectrum. It's electromagnetic radiation. A teacher demonstrates the penetration of alpha, beta and gamma radiation through different materials. Demonstration is shown in the figure below. Complete the figure above by writing the name of the correct radiation in each box. Okay, so the first type penetrates paper, aluminium, and goes a little bit into the lead, but should be reduced a little bit. The only one that can be the most penetrating is gamma. The second type of radiation gets through the paper but is stopped by the 5 millimeters of aluminium. This one is beta. And then the last one, the one that cannot penetrate through paper, is alpha. Okay. Give 2 safety precautions the teacher should have taken during the demonstration. So the first thing they should do is they should not point the radioactive source at the students. So not point the radioactive source directly at the students. Directly. They also should keep the source out of its box for the minimum time necessary. They could wear safety glasses, eye protection, gloves. They need to keep the source away from their body, so increasing distance. And they need to hold the source with tongs or forceps. So any of those would get you the marks there. So don't point it directly at students. Keep it outside of its protective lead-lined box for the minimum amount of time that is necessary while you're using it. Wear safety glasses, eye protection. Source needs to be held as far away from the body as possible, and it also needs to be held with tongs or forceps so that you're not touching it directly. For part D, the table below shows how the count rate from a radioactive source changes with time. Okay, so we've got a little table, time and count rate. Use the table to calculate the count rate after 200 seconds. Okay, so this question relies on us realising the definition of half-life. So half-life is the amount of time it takes for the count rate to decrease by half. So the original count rate is 400. Half of that is 200, which means my half-life, the time it takes for the count rate to half, is 80 seconds. So using that information, after 200 seconds, I can work out that the count rate would be 71 counts per second. It will accept 70 as an answer as well. The half-life of the radioactive source used is very short. Give one reason why this radioactive source will be much less hazardous after 800 seconds. So for this one, because it's got a really short half-life, the count rate or the amount of radiation emitted is going to reduce quite quickly. So after 800 seconds, there will be a very small amount of radiation emitted. compared to something that has a longer half-life. And, you know, it could be that small that it is nearly the same level as the background radiation. Okay, well done, guys. Thank you for having an attempt at that question. If you are stuck on anything, give me an email and I will respond. Thank you.